So alternative to practical planning experiment questions. This was the last question we did, how we can separate these compounds, sodium chloride, aqueous, ammonia, and sand. Today's experiment is calcium carbonate and kaolinite are both white solids, which are found in sedimentary rocks. Calcium carbonate can react with hydrochloric acid to form an aqueous calcium chloride, and the kaolinite does not react with the dilute acids. You are provided with a mixture of a calcium carbonate. It is a compound which is present in the sedimentary rock. So you are provided with a mixture of a calcium carbonate and a kaolinite and excess of hydrochloric acid. You have to plan to determine the percentage by mass of a calcium carbonate in the mixture. So example, if we have a sedimentary rock, some part of this sedimentary rock is having calcium carbonate. Example, these yellow spots are representing calcium carbonate. And both are white solid are there, but example, just to distinguish, otherwise I cannot draw white here. So, and the example, the green spots are representing the kaolinite. So we want to find what is the percentage of calcium carbonate is this sedimentary rock sample. Okay. So how it can be done? First, what we will do, we'll measure the mass of this sample. So we'll measure the mass of this sample, and how we can measure the mass of the sample by using which apparatus should be used to measure the mass? By a balance. So we'll measure the mass by using a balance. Then to increase the rate of a reaction, what we should do whenever solids are there and we are reacting, so we should increase the surface area. And how we can increase the surface area? By grinding or crushing them. How we can grind or crush this? Which apparatus can be used to grind or crush? Mortar and pestle. In the chemical lab, mortar and pestle can be used to grind a substance or to crush the substance. Okay. And then because hydrochloric acid can react, the hydrochloric acid can react with calcium carbonate. So we will transfer the sample, like after grinding or crushing using a mortar and pestle, we will add this mixture to a beaker, and in this beaker what we'll do, we'll add hydrochloric acid, and we'll add an excess of a hydrochloric acid. Why an excess of a hydrochloric acid? Because we want to make sure that there is no more calcium carbonate left, all the calcium carbonate is reacted. That's why we'll use excess of a hydrochloric acid. When we use more than enough hydrochloric acid, all of the hydrochloric acid will react, like hydrochloric acid will react with calcium carbonate. So there will be no more calcium carbonate, it will turn into calcium chloride. But the kaolinite will remain insoluble, or it does not react, so it will remain as a solid state. Then what we can do, we can filter. So when we carry out the filtration, the filtrate will be calcium chloride after adding an hydrochloric acid. So when we add an hydrochloric acid, all the calcium carbonate is being reacted and turned into calcium chloride. And when we carry out the filtration through the filter paper, the filtrate will pass through. And what will the filtrate here? The filtrate will be calcium chloride. But what is left as a residue on the filter paper, which does not react with the hydrochloric acid, that is kaolinite. That is insoluble or does not react. Then we can dry the residue and measure the mass of residue. How we know what is the mass of a calcium carbonate? So how we'll know what is the mass of a, like we measure the mass here, the total mass, and we measure the mass of a residue. After drying it, we measure the mass. How we know what is the mass of the calcium carbonate? So the total mass minus the mass of a residue will give us the mass of calcium carbonate. But we need the percentage, as the question is plan an experiment to determine the percentage. So what will the percentage of calcium carbonate? The percentage of calcium carbonate will be mass of calcium carbonate divided by mass of a compound, mass of a sample into 100. Okay. This is the experimental procedure. Now, how to write this in detail? Whenever you are planning experiment, try to include maximum apparatus. So first we will measure the mass of sample. How we can measure the mass of a sample? By balance. An example called this as M1. You can use the variables here. So we call that as M1. After measuring the mass, what we will do? We can crush the sample by using what? Mortar and pestle. After crushing the sample by using a mortar and pestle, transfer into a beaker. And how we can transfer? By spatula. Then add excess of hydrochloric acid. And how we know it's an excess of hydrochloric acid? Until no more bubbles or fizzing is there. Then filter the mixture. After filtering the mixture, measure the mass of residue, dry the residue and measure mass. How you will dry the residue? By using a tissue paper and measure the mass. That mass is called M2. What will the mass of calcium carbonate? The mass of a calcium carbonate is the mass of the sample minus the mass of residue. But we need the percentage. So what's the formula for percentage? Percentage of calcium carbonate will be is equals to mass of calcium carbonate divided by mass of a sample and that is multiplied by 100, or numerator multiplied by 100 divided by mass of sample. That's how we plan this experiment. Clear? Any doubt in this? Okay, plan this experiment and send the pictures now. Plan this experiment now and send the picture.